Good morning, everyone. I am Dr. Nasli Hardy, and on behalf of the conference committee, I am delighted to welcome you all to the 33rd Annual Women in Math, Science, and Technology Conference. This conference is inspired by all of you here today, students interested in science and technology and careers in STEM. Over the course of the day, you will meet and hear from accomplished women who are experts in their fields in science and technology. They will share with you empowering stories of their careers and their lives, stories of triumphs, and also what seemed like failures, but what turned out to be turning points of success. And one day, when you are all successful in whatever career you choose, I hope you will remember to reach back and mentor and pull up other girls and boys who look up to you for inspiration and guidance, because that is what empowerment is really all about. I would like to thank all of the committee members of this annual conference. They invest a lot of time to ensure the success of this conference. I would also like to acknowledge Professor Wolf, who is the founder of this conference. It is our honor to have him here today. In particular, I would like to thank my colleague, my friend, and the conference coordinator, Mrs. Marianne France. It is because of her dedicated effort over the past several months, her attention to detail and quality, that has brought this virtual conference to life. She makes us all look good. I would like to thank Millersville University, Glenna Hazeltine family, and Phoenix Contact Inc. for their sponsorship and support of this conference. Enjoy the conference, and now I invite the Dean of the College of Science and Technology, Dr. Mike Jackson, to introduce our keynote speaker.
Thank you very much, Dr. Hardy. It is with immense pleasure that I have the opportunity to introduce our conference's plenary speaker, Dr. Claire Jantz. Dr. Jantz is a professor in the Geography and Earth Science Department and director of the Center for Land Use and Sustainability at Shippensburg University, another fantastic institution in the Pennsylvania state system of higher education. While earning her PhD in geography from the University of Maryland, she worked as a full-time research associate at the Woods Hole Research Center in Woods Hole, Massachusetts. In 2005, she joined the faculty at Shippensburg University, and in 2015, she became the director of the center. Now, Dr. Jantz has spent nearly 20 years engaged in the interdisciplinary field of land use science and is recognized as a leader in land use and ecosystem change modeling. Under her leadership, Shippensburg Center for Land Use and Sustainability has become a widely respected applied research center that provides the science to support sustainable land use decisions at local and regional scales. Central to the work of the center is engaging students as the next generation of productive citizens in meaningful work that highlights the interdisciplinary nature of contemporary sustainability challenges. She has published over 30 manuscripts, invited papers, book chapters, and conference proceedings, and has received over $5 million in grants and contracts for her scholarly activities. She is a member of multiple professional societies, including the American Geographical Society and the International Association of Landscape Ecology. Outside the classroom and the research lab, Dr. Jantz enjoys cycling, motorcycling, running, hiking, her multiple pets, and her apiary. She has an exceptionally broad range of talents, skills, and interests. Please join me in welcoming our conference's distinguished plenary speaker, Dr. Claire Jantz. Dr. Jantz, I turn it on over to you.
Thank you. Thank you very much for such a wonderful introduction. And I am so pleased to have the opportunity to speak with all of you today. And I hope that at some point in the near future, I may see some of you coming through the doors of the Center for Land Use and Sustainability as student fellows. We love to work with students, and if you find any of this interesting, please feel free to look me up and do a little bit more investigation, we'd be happy to talk more with you about our work. Also, as I'm kind of going through my talk this morning, if you have any questions or comments, feel free to put them into the Q&A, and I hope that we have time at the end to talk a little bit more about any questions that you may have. So let's go ahead and kick this off. So my talk today is going to focus a little bit on why STEM is important, why women in STEM are important, and then I'll talk a little bit about the work that me and my colleagues do at the Center for Land Use and Sustainability, and I'll close with some thoughts about what your path forward might look like. So first of all, why do we need STEM? And the reason for that is that, looking from today out into the future, we have some really, really big problems to solve. And if we just look, for example, at the 17 Sustainable Development Goals that have been put forward by the United Nations, you can see a number of really, really big challenges that we are trying to address here at the local to global level. And STEM, as a set of disciplines, we invent, we create, we design, and those features of STEM disciplines are going to be critical for solving all of these problems, ranging from ending poverty to ending hunger to tackling climate change. So I hope that you're inspired to join into a STEM discipline to help save the world, because that's certainly where I see STEM playing a big role. And the next question that's relevant to our conference today is, why is it important to have women in STEM? And this should be kind of a self-evident question, right? Women bring so much talent to the table, and we bring really unique perspectives to the table. So I wanted to give an example, kind of a concrete example of why women in STEM are important. And I'll highlight Sarah Little Turnbull. Now, some of you may have heard of her because her story has become kind of famous again in our current era. But if not, I'm happy to share her story with you. Sarah Turnbull was worked at 3M, which is, I hope, a company that you recognize today. Back in the 1950s and 60s, she was a designer for 3M. And as a woman in the 1950s, she was assigned to the gift wrap and fabric section of the company, which was seen as kind of obviously a feminine arena. While she was there, she was exposed to a new technology, or what was a new technology at the time, of non-woven fabrics. And these fabrics are typically made of synthetic materials that at the time in the gift wrap and fabric division were being used to create pre-made bows for gift packages. And so if you have used a pre-made bow or received a pre-made bow, that design dates back to Sarah Turnbull's invention with non-woven fabrics. And while she appreciated the use of non-woven fabrics in the craft department, she also saw a lot of potential for more widespread use of this technology. And so she gave a very famous, or what is now a very famous, presentation to executives at 3M, where it was entitled Why? And the point of it was why 3M should invest in this new technology and use it more broadly beyond sort of the craft industry. And so this is an excerpt from the presentation that she gave to these 3M executives, where she is arguing that these non-woven fabrics have the potential to make really important technological advancements in products and material production, and gave dozens. In fact, she gave over 100 different ideas for how non-woven fabrics could be used in many different venues. So the board at the time was obviously all made up of men, and Sarah Little Turnbull was giving this presentation, and the board said, "This is really great. What we'd like you to do is make a bra out of non-woven fabrics." So, they were again focused on her identity as a woman and said, let's start out with a bra cup. And so Sarah Turnbull said, okay, fine, I'll make a bra. And this is actually her drawing of a bra made up of a molded bra cup that 3M patented. But the other thing so Sarah wasn't done, obviously, with non-woven fabrics. And another piece of her life, in her personal life, she was also helping to take care of about 3 different family members who were all facing health challenges. And she was spending a lot of time, with medical professionals and in hospitals and doctors' offices. And in the 1950s, face masks were made up of multiple layers of material. They were very bulky, not very comfortable. And so Sarah started to think about improving medical face masks. And in particular, she started to design medical face masks with the use of non-woven materials, which ultimately became the basis for the N95 mask that is now so famous, given our COVID pandemic that we continue to deal with. And so, getting to this point of a non-woven, highly effective medical grade face mask essentially took a woman who was put to work in the gift wrap and fabrics division, who was then told, use this new technology to make a bra cup. And she continued to come back with new ideas and new ways to apply this material to help save the world, essentially. So this is why we need women in STEM, because of people like Sarah Turnbull, who demonstrate over and over and over again that the perspective that women bring to the table is really critical. So let me talk a little bit about the work that I do and the work that we do at the Center for Land Use and Sustainability. And the scientific context for the work that we do is embedded in the field of land use science. And this is a field that I appreciate as a geographer because it is inherently interdisciplinary. It brings together economic perspectives, social, environmental, demographics, and all of these different viewpoints to the observation, monitoring, and understanding of how humans use land resources. And this is just kind of a smattering of the different disciplines that come into the field of land use science. And some of these disciplines you may be familiar with, others might be new for you. Where I work in the field of land use science is with remote sensing technology and with GIS. GIS, as some of you know, stands for Geographic Information Systems and represents really powerful digital mapping technology that we can use to monitor, map, and analyze patterns of land use and understand how we can make them more sustainable. The goals of land use science include observation and monitoring And in particular, land use science uses satellite observations. We use airborne observations like simple air photos to track and monitor how humans use the surface of the land. We focus on understanding how human systems and environmental systems interact with each other. There's a lot of modeling, quantitative modeling in land use science, and I'll talk a little bit more about that. We think about things like vulnerability. How are human, economic, social, and environmental systems more vulnerable or more resilient based on how we are using the land? And a grand challenge that's kind of embedded within land use science is a search for what is called a sustainable land architecture. And essentially what this means is, how can we utilize our land resources in a way that supports our environment and ecosystems, how they can support our economic and social systems in a way that is sustainable over the long term. So just to give a few examples that my colleagues and I have worked on at the center in this field, and some of them seem quite simple. For example, one of my colleagues used drone imaging to observe and monitor parking usage of parking lots in a few townships in Dauphin County and other counties in central Pennsylvania. Now, some of you may know that pavement is disastrous for water resources in particular. And so the more pavement we have, the worse it is for water resources. And parking can make up a big chunk of the pavement that's associated with many of our commercial activities. And what we found in this parking study is that many parking lots are actually much bigger than they need to be. And what that means is that the land use regulations that dictate how many parking spaces are required for a particular use probably need to be revised. So this study helped to inform what is now underway, which is a revision of land use policies to help shrink the parking requirements that will ultimately shrink the pavement that is associated with our commercial developments, which again is a win for water resources, as well as continuing to support economic development. We've also used drone imagery to help support land restoration. In Carlisle, Pennsylvania, there is a relatively new piece of land that has entered into protection. And with the Central Pennsylvania Conservancy, there are efforts to restore the wetlands, the springs, trout populations, and other natural features on this newly protected property. So we have completed sort of an initial assessment of this piece of property, again using drone imagery. But this whole project of land restoration, you can see how it could support work from geographers, environmental scientists, biologists, people who work in park and park design. So again, this is a really good example of the interdisciplinary nature of some of the challenges that we are working on, but at a very local scale. This is a single property. One of the things we're also interested in is thinking about alternative energy and how we can better incorporate alternative energy into our land use systems. So in Antrim Township, down in south central Pennsylvania, we developed an interactive web tool that users, so these can be planners, these can be residents, can sort of interact with. They can click on a particular piece of property and understand how much solar energy can be generated on that property, given its aspect, its exposure to the sun, and other environmental features. So this is a tool that we created specifically to support decisions related to bringing in additional energy resources in the form of solar panels. We've also done some work in Cumberland County, Pennsylvania, to look at carbon dynamics. So Cumberland County is in the process of coming up with a climate action plan that will help their county both mitigate the impacts of climate change, as well as creating resilience within their community to the impacts of climate change. And one of the questions that we help to ask is, how does land use change contribute to climate change? And what we're looking at here, areas in red, are areas where land use change has resulted in a carbon emission. So these are places where forests or farmlands or natural lands were replaced by residential or commercial development. And then areas in green, which you can sort of see scattered around the county, and here the southern part of the county is Michaud State Forest. And you can see some red areas in Michaud State Forest where they have harvested timber, but also some green areas where trees have actually grown back and absorbed carbon. So this kind of assessment can help planners and environmental scientists understand the carbon dynamics related to land use change. And in the case of Cumberland County, land use change has resulted in net emissions of carbon. And this may help to inform policies, for example, that might promote tree planting or reforestation in order to bring their land use dynamics in terms of carbon emissions into a better balance. We also use GIS technology to tell stories. To our west, well, to my west, I'm in South Central Pennsylvania, is the Kittatinny Ridge, which goes, actually, this mountain range goes all the way down through to Georgia and up much further into the northeast. But there's a significant piece of this ridge that goes through Pennsylvania. And it's important, the Kittatinny Coalition calls this ridge landscape Pennsylvania's most treasured landscape. It's important because it's a migratory bird corridor. It also has the Appalachian Trail following much of its length. It is a forested corridor where many stream headwaters are located. And we know a lot about the environmental and ecological components of the Kittatinny Ridge. But with GIS, we can actually use maps to tell stories to, the general public that helps to convey the importance of resources like this. So this is where land use science again highlights its interdisciplinary nature, because this is where art and design can also play a role. Communications and communication technology plays a role in helping to convey these stories that will hopefully help to build support for the work of conservationists and others who are working to protect the Kittatinny Ridge. So let me switch gears again a little bit and talk more specifically about some of the work that we have done in the Delaware River Basin. And I guess, well, I'm in the Chesapeake Bay, and I'm guessing many of you all are also in the Chesapeake Bay watershed. The Delaware River watershed is going to be to our east and is the watershed where Philadelphia is located, Allentown, and Stroudsburg. And up at the northern part of this watershed is where we have the Pocono Mountains and those types of areas. So this river basin is really important for lots of reasons. There's over 8 million people who live here, and this river basin provides water resources to more than 15 million people. So just about everybody who lives in the river basin gets their water from the Delaware or one of its tributaries, but also many of the people who live in New York City get their water from the Delaware River Basin. So that's where this river basin is kind of more than the sum of its parts, just in terms of water resources. So this is a really important watershed from that perspective. And there's a lot of focus in the Delaware on protecting and restoring water resources. So we were invited to do some work in the Delaware River Basin to try to address a multitude of challenges that the Delaware River Basin is facing. And this is our team. So we had a team that was made up of a hydrologist, a meteorologist, an environmental scientist, GIS specialist. I was the team leader, and I'll just take a minute, to sort of make the observation that on this team of 7 people, only 2 of them are women, right? And so these fields are fields where women are underrepresented, and it is rare for me to work on a team that has even one other woman on it. And so I often feel like I'm the only woman in the room, usually in a room full of very talented male scientists, but I always hope to see more women faces at the table. And so again, for you all who are here today and thinking about pursuing careers and studies in STEM, I hope that in 10, 15, 20 years that I will see you at the table for one of these projects, and that you can help to diversify these teams. But I'll also say it's nice to be the boss on these types of teams, because that's another thing we don't see very often is women actually leading these types of teams. So again, I hope that you will join me in this effort to diversify and to actually lead teams like this. All right, so with the work that we did in the Delaware River Basin, this was a huge project where we built and used a lot of different models. Again, that's something that is kind of a characteristic of land use science. There is a lot of modeling that happens, and I find modeling really fun because it's based in reality, but you can make changes. So it's kind of like modeling is kind of like a laboratory where you can run experiments, you can make different assumptions and run the model and see how the system responds to different circumstances. In the field of land use science, there aren't actual laboratories, or it's very difficult to run experiments in the real world. So a lot of our experimentation happens within models. And in the Delaware River Basin, we were interested in how land use change and climate change impacted ecosystem services. And in particular, we were focused on water resources and forest resources. So you can see that we used a hydrologic model, a tree species model, and a water runoff model to experiment with different scenarios of how land might change in the future and how climate might change in the future. And what we found was, and I'll just give a, the 20,000 foot overview. In the Delaware River Basin, like many places in the Mid-Atlantic and Northeast, over the next 100 years or so, it's going to get warmer by a few degrees, and it's going to get rainier as well. And so we have already started to see some of the effects of increased rainfall and increased strength of storms that we see in our region. And what we're seeing today is consistent with what we actually predict to see happening in the region. And this has implications for things like flooding. It also has implications for the warming in particular. These series of maps on the right, we're starting with kind of our present day here, and what we're looking at is snowfall intensity. And you can see that by the time we get out to 2100, particularly in a scenario that has the highest warming potential, there's essentially no more snow cover in the Poconos. So if any of you ever visit the Pocono region in the wintertime, skiing is a big industry up there, and that is something that will likely be losing over the next several decades as the potential for snow decreases because our winters are warming. So those are some of the things that we found kind of in terms of how climate change will influence factors like temperature, precipitation patterns, potential for flooding, that again feeds into decision making and policy making for people to either build resilient strategies to deal with those changes or to try to come up with strategies to mitigate these changes. We actually specifically looked at flood risk for a few areas, and we looked at the combined effect of climate change and land use change and found a pretty significant increase in flood risk, particularly as a result of those increased precipitation patterns that we saw. So again, one of the big take-home messages from this part of the study is that climate change is a much bigger challenge than had been previously acknowledged. So those increases in precipitation and temperature have a much greater impact on the system than do changes in land use. And so that was a really important take-home message, because much of the focus has been on land use change and not on climate change. And this helps to change the focus so that policymakers and decision makers will now hopefully start to think more about climate change in addition to land use change. And we actually, in terms of land use change, we are actually able to kind of map out places in the Delaware Basin that would be exposed to higher development pressures. So what we're looking at here is kind of a current day map of development intensity, so urbanization in the Delaware River Basin on the far left. And then in the middle and on the right are maps of future urbanization under two different scenarios of land use change. And in both scenarios, we again sort of were able to identify places in the basin where we expect to see higher development pressures. And this will again help to guide decision makers, planners, and conservationists in terms of where they want to invest their resources. We also created maps of potential deforestation in the future. So again, on the left is our current distribution of forest in the Delaware River Basin, with all of that forest up in the northern part in the Pocono Mountain region. And in the middle and on the right are places where forests are predicted to be lost. And again, we can highlight areas where where forests may be lost due to development. So that's kind of just a smattering, I guess, of examples of some of the work that we do at the Center for Land Use and Sustainability. I wanted to close with a little bit of a focus on geographic information systems, because what's embedded in all of these projects, almost every single project that we do at the center, geographic information science is a really important integrative tool that we can use to solve these issues related to sustainability. Often sustainability challenges are described as quote unquote wicked problems because they're not problems that are easy to understand or easy to address because they have so many different components. But you can see, I hope, from the examples that I gave you today that GIS can be used as an analytical tool, so we can model and map and identify areas of importance. But it can also be used as a communication tool. It can be used to synthesize information from demographics to environmental information, and so GIS has again really kind of come into very widespread use in the field of sustainability sciences. And it's something that even before we had computers, we were using these approaches. So this image on the right is an image from a very famous 1969 book about how we can use different types of geographic information to think about better ways to use the land. And obviously with the advent of computers and computer science, we can do a lot of this work much better and much faster. And GIS is recognized as a STEM field. The National Science Foundation recognizes that geographic information science is a STEM field. And it is also a field where we have some really great women working in, but it is ultimately a field that remains dominated by men. And this is an excerpt from a recent talk by a woman, GIS scientist named Maria Hochleiter. And she makes this statement very strongly, that we are long overdue to have more women in the GIS industry who are brave enough to bring in their perspective. She says, make no mistake, it takes courage. Courage to go into an industry where not so many women are represented. And this is probably going to be the case still today in many STEM fields that you may want to pursue. It may not be unusual for you to walk into the room and realize that you're the only woman in the room. And that can feel uncomfortable. It certainly takes courage. It takes confidence to be the only woman in the room. But we need to get more women in the room. And so again, I invite you all to, and certainly encourage you to continue on your path for STEM. Maybe I've convinced some of you to think about GIS as a pathway in STEM. I sure hope so. Because again, we need more women in the room. So I will sort of sum up some of my thoughts here in terms of how you all might move forward in STEM. And I'll go back to Maria Turnbull and say you should always ask why. That was one of her, Sarah Turnbull. That was one of her kind of catchphrases, is that you always ask why. And I'll also add another quote from one of my favorite TV shows, Ted Lasso, which some of you may be familiar with. Ted Lasso uses a quote of "Be curious and not judgmental." And this is a general comment for science in general. Scientists are naturally curious. I mean, it's what we do. We're always asking why, we're always asking why, and then asking why again. And it's really important to not be judgmental and to not rush to, make conclusions until you have seen, all components of a problem. Be brave, like Dr. Hochleiter said, that you need to be brave because you may end up being the only woman in the room, and that requires confidence and courage. And I know that many of you all have that. Take as much math as you can, and also coding. I use math literally every day in my job. And coding, scripting is increasingly important. And I would echo what Dr. Hardy said, that it's important for you all to find mentors now, but at some point soon you'll be in a position to be a mentor. And that is how we create the pipeline to get more women in STEM and more women at the table. And finally, I'll end with be open to collaboration, particularly with the challenges that we face today at the global level, at the regional level, at the local level. STEM fields play an important role, but certainly not the only role. And so it's important to get comfortable reaching out and working with people who are in different disciplines. That may be English, it may be art, it may be planning. So keep an open mind in that respect. And finally, I hope that you all will contribute to solving some of those problems and to help save the world. So I think that is it for me. I think we have a few minutes for questions. And I have my contact information up here on the screen as well. And absolutely feel free to reach out to me at any time. I'd love to talk to you all more about GIS and STEM and sustainability.
Well, thank you very much, Dr. Jantz, for an outstanding and inspiring presentation. It was great to also learn more about the interdisciplinary field of geography and how it connects science, technology, policy, design, and the environment and all of its inhabitants, including people. So it's a wonderful discipline that I would encourage students to learn more about. And we have great geography programs at Shippensburg University, as well as at Millersville University. So there's a lot of great opportunities for students to learn more about this discipline. And it's really important for you to get involved because you can connect with so many different areas based on your interests. Now, before we move to the Q&A session, I'd like to thank our sponsors again for their support: Millersville University, the Hazeltine family, and Phoenix Contact. I would also like to thank Keston Lyman for the outstanding technical assistance that he provides for today's conference, and honestly, everything else we do here at Millersville. We will also be putting an anonymous survey in the chat that Keston, I believe, just posted a little while back. When you have a moment, please fill out the form. Our feedback form will have the same format throughout the day. And at the end of the session, at each session you attend, you'll be asked to identify which session you're providing feedback on. The survey is anonymous, and your feedback would only be seen by the conference committee. So please be sure to fill out the survey for your sessions, as we value your opinion and feedback. Now, Dr. Jantz, the first question that I had received from the chat was actually from one of our faculty members in the Department of Geography, Dr. Cuthbert, and she had mentioned many students don't think about geography as being part of STEM. Perhaps could you take a step back and talk generally about how geography is an integral component of STEM fields?
Yeah, that's a great question. And I know that, I mean, certainly for me, I didn't really know that geography was a thing until I was a senior in college, right? Which is not unusual for many people who go into geography. It's like there's this kind of idea that geography is like, what are the state capitals, and that kind of stuff. And geography is so much more than that. Geography, what appeals to me about geography is that as a geographer, geographers are known as jacks of all trades and masters of none, right? So we do a lot of different stuff. We're very broad. And geography kind of is the intersection of, there's geographers who work in social and human systems. We call them human geographers. There's geographers who work primarily in physical systems, geomorphology, weather and climate fields. Those, we call them physical geographers. And then there's geographers who work in sort of the technical fields like GIS and remote sensing, and we call those technical geographers, right? So, and if you're right at the middle, you can have kind of branches out into all three of those areas. And so geography itself, like GIS, is kind of an integrative discipline. And so it's really it's a discipline that is well positioned to address some of these sustainability problems, which include components from all three of those areas. And I hope Dr. Cuthbert would agree with me on that. I'm sure she does.
Yes, that's wonderful. Thank you very much. Dr. Hardy?
Thank you, Dr. Jantz. Thank you for your important presentation on a topic that affects and will continue to affect all of us, and also for your very strong message of encouragement and inspiration for women in STEM. We do have a question from Dr. Daniel Woba, the president of Millersville University, and he says, thank you for your comprehensive presentation. Does the SU-CLUS staff have plans to establish a summer undergraduate research program, the REU, focused on female students and potentially students from underrepresented groups?
That is a great question, and it is definitely something that we have looked at and we continue to look at. So what the president is referring to is a program that is funded by the National Science Foundation that creates research opportunities, like what you hear in the name, for undergraduates. And there are some components of that program that specifically focus on women and underrepresented populations. And we have certainly have taken a dive into that program to try to think about and understand how we might do something like that at SHIP and under the CLUS. And potentially maybe it's something that Millersville and Shippensburg could collaborate on. So if there's any of you there at Millersville who would like to think about that with me, I would sure be happy to have that conversation for sure.
Yes, we would be. So that's
wonderful.
Yes, and that's great. And so thank you very much for that. And we had actually several questions asked, not only in the Q&A but also in the chat that we received, and a couple of them addressed this next question, which was, when did you know that you wanted to get into GIS kind of work? What was the turning point or the thing that really piqued that interest?
Yeah. Well, when I was kind of in middle school and high school, I quickly kind of understood that I really liked the outdoors, and I liked some aspects of biology and ecology. I had a great biology teacher in middle school, a fantastic math teacher in middle school, both of whom were women, who were really influential in helping to build my confidence in the sciences and in math. When I went to college, I had a lot of trouble figuring out what I wanted to do, and that is not unusual. That's, many college students are not quite sure where they want to settle on. I started out as an English major because I could write, and I was still nervous about declaring a major in the sciences. Actually, I started out as an art major, and then I became an English major. And then I actually took a semester off because I was like, I don't know what I want to do. And then I came back, and had finally said, okay, I'm going to try this kind of STEM approach, and I went into basically ecology, but I was also taking a lot of classes in anthropology, so I couldn't quite, figure it out. And then my senior year, I took a class in cartography, which is map making, because I loved maps, and that was in the geography department, and that is when I realized that geography was a thing and it was something I was really interested in, but I didn't find it until the very end of my program. That was also at the very beginning of when we were using computers to make digital maps. And so I came in at the point where computers were really starting to launch GIS as a field. And then when I went into graduate school, I chose to go into geography based on one class, but also with the awareness that I had kind of found what I was looking for. And that's often how it happens with undergraduate students. You take one class and all of a sudden it's like, this is speaking to me. And that's the experience I had in that cartography class. And then going into graduate school, I went into the University of Maryland at College Park, which has an extremely strong component related to geotechnology, remote sensing, and GIS and quantitative modeling. And I loved it, and I still love it. No regrets.
That's wonderful, because, and I'd like to emphasize that in particular to the students, because many of the geography students that I meet have had this very similar experience. They took a course and just realized how much they loved it and how much it could go ahead and just impact a variety of different areas that they were interested in. And so again, if you're thinking about potential majors to explore as you're thinking about colleges, please take a look at geography, because you can go ahead and connect with a variety of different fields that can connect with your interests. Dr. Hardy?
Thank you. Dr. Jantz, one thing that we know from experience, and certainly what the conference stems from, is the importance of having role models and mentors who inspire us and who can just, and who show us the way in many cases. So I'm going to combine two questions in one, if you don't mind. So Sarah Turnbull, I assume, was one of your mentors. So one question is, at what age was she hired at 3M? And another is, who else were some of your mentors?
Yeah, I think Sarah Turnbull was in her late 20s when she was working at 3M, and she had a long career at 3M, and actually, now she's passed away, but she has had a huge influence on particularly on the design discipline. And so there's a Sarah Turnbull Institute of Design today, and again, her ideas of always asking why and failing multiple times, as you said in your opening comments, Dr. Hardy, that's part of the deal is failure, and she was very comfortable being the only woman in the room, which I think was unique at the time, but also important for her success and influence to walk into a room, full of very influential men and just, tell them what they need to know. Some of my other role models, when I was and as I said earlier, my middle school biology and math teachers were very influential for me. And when I went into college, I worked very closely actually with a female professor who was an anthropologist, a cultural anthropologist. And I did research with her while I was also at the same time studying botany and ecology and cartography. And so she helped to again sort of balance out this, quantitative STEM approach with the social science approach. And so that was really important. When I went to grad school, there were two women faculty. um, and I really wanted to have a woman as my PhD advisor. And so I ended up working with Martha Joris, who is now a retired geographer, but she started her life as a lawyer and then came into geography later on. The other woman on faculty is a woman named Dr. Ruth DeFries, and she was and is an amazing scientist. She actually won a MacArthur Genius Award for her work in remote sensing of global ecosystems. And so having women like that, even though there were very few of them who were, real leaders in the field was really useful.
Great. Thank you very much. Our next question was from Kevin, and Kevin asked, Dr. Jantz talked about parking updates and changes. Because there is money, sometimes big business involved, do cities and towns take the evidence seriously?
Kevin, that's a great question. And you actually put your finger on another, piece of land use science that, it's not just providing the evidence, it's how you communicate it. You have to have an understanding of the different stakeholder groups. So some of the stakeholder groups are environmentalists and conservationists, some are commercial, business, real estate interests, and then some are the decision makers at the municipality. So when you are talking to a group of people, you have to know who's in the room and be ready to communicate across a pretty broad spectrum of interest groups, right? So it's not just here's the science and drop the mic and walk away, right? It's a lot more complicated than that. And I mean, in the case of parking lots, specifically, and actually in many of these, in some of them, not all of them, but developers like the idea of not having to put as much pavement down, right? Because it's less money for them to develop a site. So in that case, I think there's actually some buy-in from the developers to adjust to new regulations. I'll also say that where there is conflict or friction is around this issue of how development affects water resources. Because in the Chesapeake Bay watershed, in the Delaware River watershed, water resources are really important. They're important to protect. And when we develop a property, we have to mitigate that development in terms of its impacts on water quality. And that adds to the cost of development. And so that's one place where there's friction, certainly between environmental interests and real estate interests. But something like, let's have parking regulations that don't require as much pavement is, I think, seen as a win-win, for both sides of that argument.
Excellent. Thank you very much.
Thank you, Dr. Jantz. And the question and the answer addressed something that you had mentioned in your when you rounded up your presentation, which was the collaboration, right? You're not working in a silo, but to be successful, you have to be able to connect with other people and collaborate with them, because it's a combined effort and it's all the richer for that. Mike, do we have time for one more question?
I believe we have time for one more question.
All right. Well, Dr. Jantz, this question is, have the questions asked by land use scientists changed by the COVID-19 pandemic?
Absolutely. We are, in so many ways. So one of the projects I worked on recently, kind of at the very beginning of the pandemic, I was completing it, was a housing affordability assessment for Cumberland County. And that was at the time when the real estate market had, shut down. You couldn't sell a house, you couldn't buy a house. And people were worried about how their jobs and income would be impacted by COVID. And so as part of that housing study, we were able to address in a small way, because it was at the very beginning of thinking about how do the economic changes going along with the pandemic, how is that going to affect people's ability to house themselves, to purchase a house, to rent a house, or rent a housing unit. And because the real estate market is very competitive in central Pennsylvania, so it's very expensive. But then at the same time, you have these economic changes that might prevent people from being able to afford housing. And so just within the housing realm, there are a lot of new questions popping up that we are trying to address.
Thank you, Dr. Jantz. Mike, it's 10 a.m. I know that.
It is 10 a.m. and would like to, because we have other sessions that people need to be prepared for. So we'd like to just thank you again for your questions and for attending today's plenary conference. I would like to thank Dr. Jantz on behalf of the committee for her outstanding presentation. We would like to thank our sponsors for this conference and for the workshop mentors and facilitators who you will be interacting with later today. Thank you, everyone. Please be sure to enjoy the remainder of the conference. Thank you.
Thank you very much. Thank you, everyone.
Enjoy the conference, everyone.